Welcome back to the lecture of biological wastewater treatment. In this part we will talk about the characterization of wastewater. I will make it small, somewhere disappearing. Yes, I've got this material mainly from Willi Guya from the Airwerk Zürich in Switzerland. Finally, what are the aims of wastewater characterization? Why we do need to do this? As a first, we need an easy analysis and understanding of the significance of the components. Finally, we have to calculate the magnitude of loads, concentrations in the wastewater. And of course, we have finally to have knowledge about the magnitude of concentrations of the treated wastewaters. Also finally, we have also to control the emissions. We have here a lot of parameters that are available in the world. We have here billions of organic components. Finally, even though if we have to measure 1000, which is easy to find, it would be impossible. Therefore, we need to define so-called subsets, some parameters, which are describing the behavior of a group of components. Finally, we are distinguishing between suspended solids and dissolved components. And in the wastewater field, the separation is done by a filtration with a pore size of 0.45 micrometers. Yes, dissolved and suspended, and inside this dissolved components, there we have as well pure substances or elements, like for example heavy metals or components of special significance like ammonia or phosphate. Some parameter is a subset of contaminants in wastewater of special characteristics, and the coverage depends on the properties of the analytical process. So this is a sum parameter which is widely used in wastewater treatment, and we have pure substance. This is only one element or one component which can be detected specifically. The separation of this particulated material from dissolved material is done by filtration with a pore size of 0.45 micrometers. Finally, everything which is in the filtrate we treat as dissolved component. And in this case we can find the first sum parameter, also the total suspended solids are those substances that remain after filtration in the filter, and the filter finally is then dried at 105 degrees centigrade and finally whitened before as well. And so from the difference we know the mass of suspended solids that are separated, and finally divided by the filtration volume we can calculate about the concentration of total suspended solids. Also finally, this separation method is also used to distinguish between dissolved and suspended substances. The dissolved substances passes through the membrane filter, suspended substances remain on the membrane. And typically we are choosing for the analytical method this 0.45 micrometers. For special topics there are other filters as well important. Sometimes we want to know what is the amount of organics in the suspended solids, and therefore we have another sum parameter, the volatile suspended solids. In this case we are growing this dried filter at 650 degrees centigrade. Also finally, this is also important, not a very high temperature, because we have as well carbonates that can be destroyed. And then normally the organic material is transferred, also oxidized, and vaporized, and we are measuring the remaining, and from the difference we can detect what is volatile. And from this part we can calculate with the same volume as for TSS the volatile suspended solids. The volatile suspended solids are a subset of the total suspended solids. Also this mainly is used to calculate the sum of organics in the total suspended solids. Also we have here as well like grit or sand or something like this, or precipitated material which is not organic. But finally, if we have 100% organics, we will also don't measure the same as 100% volatile suspended solids, even though in bacteria there are components inside that are not volatile. Finally, if we oxidize bacterium, there are still some ashes remaining, which are phosphates and sulfates and so on. And this is in the around about 8%. Yeah, organic compounds, they place a big matter because we want to know that they are biodegradable. And finally, if they are biodegradable, they causes growth of microorganisms. And finally, they need oxygen, or they are consuming oxygen. And oxygen is only soluble in very poor amount in water. This is around about 10 milligrams per liter. And so this is depleted very easily. And if we are entering organic components to surface water, finally then we have unrestrained growth of microorganisms, and easily we are becoming anaerobic zones, also zones without oxygen, and this leads to unwanted situations. There are fish dying, there is an unpleasant smell, and all the stuff that we don't want. And finally, the organic matter produces other biomass, and finally we have maybe some silting in the water, which is also not wanted. Therefore, we have to know what is the amount of organic material and maybe as well biological degradable. As first, we can have a look to one characteristics. Finally, the organic material can be oxidized to CO2 and water. And finally, if we are oxidizing all organic material, we can calculate the amount of oxygen that is used to oxidize all this material. Also, for example, if we have one molecule glucose, then we can oxidize this completely with 6 mol O2 to CO2 and water. And then we have 180 grams glucose is 1 mole, represents 192, also 6 times 32 grams oxygen. Also finally 1 mole glucose is then calculated as 192 grams COD, chemical oxygen demand. We will not do this with oxygen. We will use a very potent oxidizing agent, chromium permanganate. Finally, these microorganisms themselves also consist more or less of the singular formula. We will see this in the next unit. More or less C5H7NO2, and then we can also calculate the COD of 1 gram microorganism. Finally, we are doing this in this way. There's the question how much oxygen represents 1 mole nitrogen. This is a good exercise to do. So we have here this formula for microorganisms, C5H7N CO2, which we need a special amount, let's say A oxygen. And this leads here to B CO2 plus C NH3 plus D HO2. Yeah, finally we have 4 unknown A, B, C, D, and yeah, as this is open in stoichiometry, we have this nice elementary balances. The number of C on both sides of the equations has to be the same. Also therefore we have here 5C has to be the same as BC. Therefore we know B is 5. Then we have H, there we have 7 is equal 3 times C plus 2 times D. Then we have N, this is here 1, is equal C. Yeah, from this we can extract D. We have then 4 is equal to D, and finally therefore we can calculate 2 is equal D. And then we have the oxygen balance. There is 2. Let's make it a little bit smarter. O2, we have there 1 plus A is equal B plus 1/2 D. Also from here. Yeah, we know that B is 5. And we know that D is 2, also plus 1 is equal A plus 1, and then we can eliminate directly this one. And then we can write our formula C5H7NO2 plus 5O2, resulting in 5CO2 plus NH3, and C we have 1 plus D was 2H1. To check the C balance, 5, 5, the N balance, so here should be 7. There we have 3 plus 4, 7. The hydrogen, the N balance, 1, 1. And oxygen, we have here 6, and here 5 and 1. So this is complying. Yeah, 1 gram was 113 grams per mole, and this was 5 times 32. This is 160 grams O2 per mole biomass. And therefore we can extract that 1 gram biomass equals 1 point, what I have calculated for somewhere, gram COD. Or vice versa, 1 gram COD biomass represents 0.7 gram biomass. Okay, this is a short example how we can calculate also with COD. So we can go ahead. We can make use of another characteristic of organic components. All organic components are containing carbon, and we can detect the amount of carbon. Also the organic bound carbon normally is measured either as a dissolved organic carbon, this is only represents the dissolved part of the carbon, or the total organic carbon, where which is unfiltrated carbon. Yeah, TOC and COD are related to the same subset. Also finally of glucoses. In this case we are only taking a look to this 6C, and therefore 180 grams glucoses represents to 6 times 12, also 72 grams DOC. Yeah, normally this is measured by incineration of this organic material, and the formed CO2 is detected after removing of the inorganic CO2. There's another mainly historical parameter which represents the biological part. This is so-called BWWT. This is the oxygen demand of microorganisms within 5 days at 20 degrees centigrade for the biodegradation of the organic components. Yeah, also because microorganisms are growing, and we have here already learned biomass also represents COD. The BWT is always smaller than the COD. On the other hand, maybe we have also components that are not biodegradable, and therefore the BOD is also smaller. The BOD is also a subset of the COD. Finally, this parameter is frequently used for the description of biodegradation or not, but this is very dangerous. Normally, if this relation BWT to COD is 0.2, oh, this is not biodegradable. But finally, you always have to make a test with adapted microorganisms to be sure that this component is not degradable or not. Yeah, then we have special characteristics in the wastewater treatment. Normally our wastewater is not coming evenly during the day. We have peaks and at a time where there is a low amount of wastewater. Also under normal weather conditions, we call this dry weather, we have maybe more influent during the day than during the night. Yeah, everybody is sleeping and the water consumption is quite low. Yeah, this typical hydrograph we can observe. If you have very huge sewerage systems, this becomes flatter because the wastewater also is many hours on the way to the wastewater treatment plant. Additionally, we have sometimes stormwater events, heavy rain showers. And even though if we have a separated sewerage system, there is an impact to the water flow, and there sometimes we have high peaks. This has to be covered. Yeah, finally, we are calculating from this cumulative frequency curves our values. Also finally, this is a sorted list of all indicate loads of BOD, kilograms BOD per day. So finally, the sorted list is then separated about the frequency. And finally, this can be read, for example, for the 50% value, we are going here, that in 50% of the cases, the BOD load is smaller or equals 3,440 kilograms BOD. Or the 80% value, in this case, in 80% of the cases, the BOD load is smaller than 4,690 kilograms BOD. Yes, and this is a quite important approach to detect for statistical dimensioning what is the parameter where we are making the calculation for the dimension of a tank volume, for example. If we are going to the stormwater event to the highest level, then we have in this case here 9,000 kilograms, and this would be the double the amount, and finally resulting in very huge volumes for the treatment plant. This is done. Now we are coming to poor components we have here, besides the organic loadings, we have here nutrients. Also very important nowadays is the phosphorus. Phosphorus is a nutrient. This we also don't want to have in the environment. But phosphate is an essential nutrient for all organisms. 1.5% is the content of phosphorus in all living material. Also not storage material, as in biomass in this case, and therefore it is crucial. In other cases, it's also a source-limited resource. It is produced as phosphor rock, a limited resource, and we have to remove it from the wastewater, also in case to recycle it. Yes, finally, in many waters as well, phosphorus is a limiting nutrient. Finally, if we have too much phosphorus in, for example, the lake, then we have an increase of biomass and the water can be eutrophicated. This was the case, for example, in Lake Constance. When I started studying, the phosphate concentration went up. But 1949, I guess, a commission between different countries, Bavaria, Baden-Württemberg, Switzerland, and Austria, had found there can be a coming problem, and then they started programs. In the 80s, the phosphate concentration was quite high, and then they stopped, and nowadays the phosphate concentration is very reduced due to good wastewater treatment practice, so that the fishermen are complaining that there is only a few fishes and very not really fat fishes in the lake, and they are supposing to fertilize the lake to get more profit from fishing. Finally, in textile detergents and also in other detergents, there was also large quantities of phosphates. Finally, in textile detergents, this is a long time prohibited in Switzerland since 1968. I think in Germany this was the same. Also in this area of years, this was also banned from textile detergents. We have here this washing detergents, and until a couple of years, they are containing a high amount of phosphates. And nowadays, I think since 2 years, this is also banned from other detergents. This is important. Phosphorus we can measure in different types. The first important and interesting value is the total phosphorus. How many phosphate is there in the water? This sizes up all forms of phosphate in the unfiltrated sample. This is organically fixed mineral precipitation products and orthophosphate. The special analysis. Orthophosphate covers the sum of all phosphates in the water, which is hydrogen phosphate, dihydrogen phosphate, and phosphoric acid. And this is a subset of total phosphate. This is a form where microorganisms can take in the phosphate easily. Maybe to say, to measure the total phosphate, we make the destruction of particulate phosphate and polyphosphates. You're cooking in a strong acid, which is transferred all to orthophosphate. And this can be measured adding some chemicals photometrically. Nitrogen is as well a nutrient. Finally, this is important because it's integrated in proteins. Biomass contains in this range 4 to 7% of nitrogen, also a quite crucial factor, but this is only in very few waters a limiting factor, normally in coastal zones in the sea. Finally, nitrogen has also negative effects. Ammonia and nitrate shows fish poisons behavior. Ammonia also causes oxygen consumption, this we will see. And yeah, nitrate in drinking water is a big issue. But this is mainly related to agriculture. Yeah, the ammonia is in different oxidization forms. We have the reduced form, -3, is ammonia or ammoniac. Also this depending on the pH. And normally we are telling ammonia N, and this means the sum of ammonia and ammonium. We have elementary nitrogen, then we have nitrate +3 and nitrate +5 oxidation rate. And also we have organic bound nitrogen with the oxidation number of -3. Yeah, the total Kjeldahl nitrogen is also a sum parameter. This covers the organically fixed nitrogen, as the proteins, and the ammonia. Ammonia, therefore, is a subset of the total Kjeldahl nitrogen. Yeah, total Kjeldahl nitrogen is meant if the unfiltrated sample is analyzed. You can also detect the dissolved Kjeldahl nitrogen, which is done after filtration. And this we can call dissolved Kjeldahl nitrogen. And finally, ammonia is also a subset of this dissolved Kjeldahl nitrogen. Normally, the solution is also treated in a way that all organic nitrogen is transferred to ammonia nitrogen, which is later on measured, also by adding some chemicals and then photometrically detected. Yeah, ammonia is a poor substance. And finally, what we are talking about is the sum of ammonia and ammonium N. Yeah. Nitrate and nitrate are also poor substances. They are produced by the oxidization of nitrogen components. And normally they are not in the inflow of wastewater treatment plants, but they are produced during the treatment. Yeah, beside these interesting components, we have other candidates which are important for wastewater treatment. Yeah, one is the alkalinity. Also finally, this means the concentration of bicarbonate. This is a capacity sum of poor substances. Also finally, this is alkalinity means the binding capacity of acid. This measures the pH buffer capacity of the water. And finally, we are measuring the amount of acid. This is necessary to adjust the pH of 4.3. And in the wastewater, because bicarbonate is the dominant buffer system, this we are putting together. Finally, if we have bicarbonate in the water and adding some acid, this reacts to carbonic acid, and this is dissociated to water and CO2. And CO2 is stripped out, and therefore the pH stays constant. Normally we have a range of 5 to 8 moles alkalinity in wastewater. We will see that some processes in wastewater consumes alkalinity, and sometimes we have to be careful if there is sufficient alkalinity in the wastewater. In many wastewater treatment plants, they are adding additional alkalinity. And the pH is also an important topic. It's also a poor substance and activity. Finally, the activity of the protons that are reacting in water to H3O+. Now, the pH affects the solubility of salts and also the activity of microorganisms. Now we will see the effect on enzymes, and therefore this is quite nice. The typical range in wastewater is between 6.7 to 7.5. And sometimes in water bodies we are observing higher pHs due to algae growth. Finally, the definition is that we are detecting the negative logarithm on the base of 10 of the concentration of protons in the unit of 1 mole per liter. Yeah, what is to know more? Sometimes it is quite complicated to get data. If you want to plan some treatment plants or sewage systems or what else. And here one quite good thing is to use the personal equivalents. Also, this depends as well in the region of the world, but in Central Europe, normally every person produces per day 60 gram BOD, 120 gram COD, 70 gram total suspended solid, 11 total Kjeldahl, nitrogen, and 2.5 gram total phosphorus. And after pre-treatment, we can reduce these organic components and particulate components, but nitrogen and phosphate stay dissolved in the main part. And nowadays, the pre-treatment is shorter. And if we know these values and we know the number of population, then we have a good idea about the loading of a wastewater treatment plant. Yeah, what we have to fulfill, this is mainly described in the EU directive. And finally, this is transferred from national laws, at least. Maybe they are stronger, depending. And therefore we have to fulfill the concentration of 25 milligrams BOD5 or a reduction of 70 to 90%, which is normally not a big issue. The COD below 125 or 75%, which is for municipal wastewater as well not a big issue. The total suspended solids we have to remove to 90% or 35 milligrams per liter. Also for bigger plants, for smaller, they are allowed a little bit bigger. Yeah, for P and N, this is mainly the challenge. We have to remove phosphate up to 80%, and normally it should be lower than 1 milligram per liter P. Nowadays, from the German law, I think from 2024 on, we have to recycle at least 80% of the inflow. Total nitrogen we have to bring down to 15 milligrams per liter N, or even more for bigger plants, 10 milligrams per liter N, or a minimal percentage of reduction between 70 and 80%. Finally, you can choose 70%, maybe is easier than 10 milligrams per liter. This depends, but very important is how to make the sampling. So in the EU directive, there is a 24 hours mean value, and finally, depending on the size, there are sample days foreseen. And for example, if you make a sample every day for a big wastewater treatment plant, you are allowed in 25 days to have higher values. This is also accepted. In Germany, normally you have a qualified sampling method, which means 5 samples within 2 hours, and 4 values must be below the control value. We will talk about this. Finally, the EU directive is almost 30 years old, and new things are coming up, like micropollutants, microplastic, and resistances against antibiotics are not covered by this directive. And finally, the implementation of the Water Framework Directive from 2000 the quality aims are not reached. Also in Germany, they are far away from reached. Also there is a lot of things to do. Finally, the idea was to go to the emission path to see on the other side has to be done something. But finally, there was no change in the emission standards in the last 30 years. And maybe in this field there is coming more pressure to the wastewater treatment plant, and so we have to develop as well new technologies. Also this is given the ecological status of surface water bodies in Germany, and you see a very high and good, also blue and green, you will not see. Mainly is moderate, poor or bad. Yes, and as well you see here the coverage, also normally the failure of the achievements is good. Also there is a lot of things to do. Okay, thanks.